Welcome back to this tutorial. In this tutorial we are going to finish off implementing the single responsibility principle, and I'm going to show you how small the player class will be after we are done, and we are going to be pretty amazed, I hope, about it, how much we can extract from this class and make sure that we have more maintainable code and more easily read code. So let's open up the player input script. Great. This script will be a bit different because we will need to make sure that we can expose the movement direction as well as the event of the player passing the event of fire1, so the axis fire1 for when we want to interact with the NPCs. So we are going to write this class from scratch. We're going to create prop tab twice. We're going to change the name the type to vector2 and tab to move to the name, and let's call it movement input vector. Okay, enter, and we are going to set the set value to be private. Now, in addition to our movement input, we will need to know if our player has pressed button to interact with our NPCs. To do that, we are going to use public event action. So this is the delegate. Alt-enter to be using system, so system library at the top here, so we can use this action delegate. And this is basically the same what we have on our buttons in the UI. So when we want to click a button, we can add to it an event, so the click will in turn call another method. And that is what we are going to do here. We are going to invoke this action, so call any method that is listening to this action whenever the player presses the interact button. And this is a publisher or subscriber pattern if you want to read more about it. We are going to use this, and let's call it on interact. Let's call it event. And we are going to use this inside our two methods. Let's create update. Okay. And basically what we would do is we would call if input dot get axis raw, and let's get it the fire1 for our action, and we would then check if this is greater than 0. We would call on interact event question mark to check if anything is listening to it, and invoke, so only invoke it if a method is assigned to it to listen to this event. And we would also do something like movement input vector equals new vector2, and we would get the input dot get axis raw, because I'm not interested in smoothing, and we are going to type horizontal. If you are not sure about what is going on here, I'm going to show you in a bit. And we are going to pass a y value. Let's copy the statement, and I'm going to pass here, instead of horizontal, vertical. And this would be how you would generally write this code, but we are using the single responsibility principle. So we do not want this method to have two responsibilities of getting the axis and getting the movement input vector, or rather, we would like it to only call a method that will in turn know how to and when to invoke this event or how to get this input vector. So instead, we are going to select this code, right click on it, extract a method, and we are going to call this method get movement input. And the same thing we will need to do on this. Actually, this is not get movement input, this is get interact input. Okay, and we are going to choose this, right click on it, quick actions, extract method, and let's call it get movement input. And this is also a part of single responsibility principle. So here, this update contains of two methods, and each of those methods know exactly how to get what it wants to get. The update needs to only know which method should be called every frame of our game. And that's it for our input. So let's go back to our Unity. Okay, great. Let's open up the player, since our player has already the player input. And by the way, if you are not sure about the axis thing, I'm going to go to the top menu, edit, players, project settings, and input manager. And here you have the axis, and you can see that horizontal axis is the left right, vertical axis is up down, and fire 1 is left control or mouse 0, so we can use it to get the correct input for the joystick as well as for the keyboard. You can read more about it. For now, let's focus on the solid principles. So we are going to open up the player and make sure that we are using this player input. So let's open the player script. Great. We will need to now get the reference to our player input. So let's create a public player input. Let's call it player input with camel case. And we are going to get the reference to it inside our start method. So player input equals get component of type player input. Okay. And now let's find out where we are using this to get the values that we will need to get. Now we are getting the movement vector inside our player input, so we can basically delete it from our player script. And now we should have some errors, so we will not exactly know where we should use this. So here we have received this player movement, and we have not normalized this. So we can right click on this player input, right click, go to the definition. Okay, and what we can do is inside our get movement input, let's call movement input vector dot normalize. Okay, let's go back to our player. And now we do not need to call it inside this update, we are calling it inside our player input. Great. Again, we are calling this get axis raw fire 1, and we are calling on it player AI interactions interact. So what we are going to do is cut out this line, delete the update altogether, and inside our start, when we get the player input, we are going to call player input on interact event plus equals, and we are going to assign this player AI interactions interact, and we cannot assign it like this. So instead we are going to use lambda expression, so empty parentheses and lambda expression, and we are going to assign this method as an anonymous function, and we are going to pass it on interact event. So when this event is triggered, we are going to call this interact, and this in turn will shoot array and interact with NPCs. Okay, so now in fixed update, what we will need to do is to pass to the player movement move player our player input dot movement vector, and I think we have a different name for it. So dot movement input vector. Let's copy this name because we will need to paste it below. Check the magnitude. So we have a code that interacts with UI and animator. We will need to refactor it. And basically that's it. So let's save it. Let's go back to Unity. Great. Let's press play and let's see if everything works still. And we can see that we can use the movement input. We can see in the scene view that we can shoot array, and we can basically interact with everything else. And now our player has additional scripts that get rid of the input from the player and use the player input script to get the input from the Unity and pass it to whoever needs it. Okay, let's finish off by refactoring this animator to the player animations. So I'm going to open up the player animations script. Okay, so we have our player animations. I'm going to delete everything from this script, and I'm going to use the Visual Studio to move the player side by side so I know what I can refactor. And here we can see that we have our animator. So we want this player animations to take care of playing the correct animations based on the player input that will be passed through the player script. So let's extract this public animator player animations and paste it to our player animations. Now we can create this reference to this object inside our player. So again, let's create public player animations, call it player animations with capital A. Great, let's get the reference to it from the start. So we are going to maybe get it at the start of the start method. So player animations equals get component player animations. Okay, and now let's slide it down. Let's see where we have issues. Here we can see that in the fixed update, we are calling the movement input vector, getting this value, and if this is greater than 0, we are calling this correct animation on the walk. So instead, we are going to create a method inside our player animations. So public void setup animations. We are going to pass here vector to movement vector. Great. And what we are going to do here is if our movement vector dot magnitude is greater than 0, since we do not have jumping functionality, we can simply call here inside this the player animator set bool, and if the magnitude is greater, we want to set it to walk, else we want to set it to false, and if the magnitude is greater than 0, we are going to set it to true. Okay, we have some issues here, so I have removed this parenthesis for some reason, so here it is. And that's it for this method. So now we can call inside our fixed update, we can keep this UI set active. Let's delete this else statement, and inside our player movement, what we will need to do is actually below this player movement, move player, we are going to call player animations set with the lower p, set setup animations, and we are going to pass here the player input dot movement input vector. Great. Now let's slide down to the move player to see what is going on here. Again, we have this player animations, we don't want it, and here inside our move player we can see that we are calling player movement and player renderer. So let's cut it out from here. Let's delete the method player movement since we do not need it. Let's delete the call to this method from the fixed update and instead paste the code that we have copied. So now we have player movement move player, player renderer render player, and we need to pass to them the player input dot movement input vector instead of the movement vector. Great. So now you can see that we are calling on our helper methods the correct method and passing the data, and that's all that the player is interested in. And now we have this if statement remaining will be refactored, and we have this receive damage method, and that's it for the player. So let me drag it to make it full screen. Okay, so we can already see that the player starts to have only one task of exchanging informations. Well, of course, we have this UI window set active false, and you can extract it on your own to make it into a separate UI class. And we have this receive damage. Let's right click on it, go to definition, right click on it, find references, and you should find one reference. Inside our NPC enemy, we are calling get hit, and we are calling on the player receive damage. Well, this is logical to make the NPC enemy only know that the player should receive damage and not anything else. And we could certainly refactor it even more, and we could refactor this UI window and text field into a separate class. So give it a shot, extract it inside a UI controller, for example, and make sure that you call UI controller here instead of calling the text and game object directly and setting the UI window active and setting the text as text. And in the next video, we are going to move on to the open-closed principle. Let's quickly go back to Unity. Okay. And now we can directly control what is going on. Now, before we test it, let's assign the animator. So the player sprite has the animator. So we will assign the animator inside our player animations. And let's press play, and we should be good to go. So let's press play. And we can still run correctly. We have the correct animations being played. We can interact, we can hear the sounds, so everything works, and we have refactored our code to almost completely fit the single responsibility principle. If you're enjoying this series, be sure to leave a like, leave a comment, let me know what you think, and I will be seeing you in the next video about open-closed principle. So see you there!